Hi guys, in this video we've come across myths and facts about organic farming. Before watching this video, you have to like and comment below to watch great video clips to enhance your knowledge. The no use of synthetic chemicals in agriculture is usually not viewed as organic farming. Although this is a feature of the method to some extent, nothing is said about the involvement of organic management or why certain technologies and practices are chosen over others. It may be a failure of productivity, financial, and environmental sustainability if synthetic inputs are not used and nothing more is done. By default, organic agriculture. The concept that biofarming was like all agriculture until the middle of the 20th century, or at least agriculture, is likewise far from reality. The role of science in organic farming. The challenge of organic farming is sometimes unscientific, or even worse. That's not the case. The scientific method plays a crucial role in the understanding of how agriculture and ecosystems operate, and how they can help sustain our food production and other ecological services. As such, science has, and still has, a particularly vital role to play in developing and validating organic agriculture concepts. For example, Nigley et al. 2008. While we continue to debate the limits of methodology, particularly in the comprehension of complex systems, the scientific method, which has greatly aided the growth of human knowledge and understanding, is critical for this project. On the other hand, technology, so often closely linked to science, is another matter. Admissibility and additional accessibility of particular technologies, such as renewable or nuclear, genetically modified or non-GM plant cultivators, and of fertilizers, pesticides, and farm mechanisms that led to the Green Revolution, however well established in science, should depend on a careful cost-benefit assessment covering economic, environmental, health, social, cultural, and ethical aspects. Science may well be crucial to assisting us in carrying out these evaluations and examining the evidence of various possibilities. However, different people can draw distinct conclusions about the sustainability of a specific technology with their different life experiences and viewpoints on the importance of additional costs and advantages. This is up for discussion and not necessarily a pro or anti-science approach. The wide variety of concerns expressed as a concept in the development of organic agriculture also explains why the idea of organic farming by its promoters can be regarded as inconsistent. Some of these individuals are lay people who may not have the same scientific understanding or communication skills as professional scientists. Impacts of organic farming practices. Minimizing external inputs. Although organic standards are proper and most synthetic fertilizers or pesticides are forbidden, synthetic molecules are different from natural ones and do not contain the rationale for this. While lay promoters may communicate the idea of chemical-free food in some instances tortuously, it is nonsense because all foods include chemicals, not to mention all creatures and elements. The primary reasons why synthetic inputs to organic standards are excluded or minimized are conserving non-renewable resources and applying the precautionary principle to provide environmental repercussions. This is shown in the thoughts of A. To endeavor, to the extent practicable within closed circles, to work with renewable resources from local or farm sources to save resources and increase autonomy. B. Endeavor to collaborate with the agroecosystem to deliver and sustain the productivity of ecosystem services as much as is feasible. This, however, has the potential to impact the soil and plant and animal health as the way nutrients are administered changes. Depending on the type of nitrogen fixed nitrogen moves through soil ecosystems. See, for example, Brady, 1984. Nitrate ions are more susceptible to oxidation and are commonly used in industry, whereas biofixed nitrogen is initially attached to soil protein. Organisms and plants are finally disintegrated into ammonium ions that plants can take up via the mineralization process. However, ammonium can also be kept in the soil as a positive ion that is harmful to charged clay particles and humic acids, and is not released as nitrate but may be oxidized to nitrate if not kept in the soil or used by plants. It should be used as a positive ion. Plant-absorbed surplus ammonium cannot be saved, but the excess nitrate ion can be held in a sapphire. Stored nitrate may act as a nutrient reserve to enable more rapid growth and reproduction for pests, for example aphids, and infections, leading to plant health concerns. Huber and Watson, 1994. Excessive vegetable nitrate content has also been of significance for food safety regulations because of worries about potential human health effects. Nitrogen as food from plants supplied with mineral fertilizer or from organic manure is also reported to differ. However, organic manure supplies soil nutrients and organic matter, providing the soil ecosystem with a source of energy not available with mineral fertilizers, stored in carbon molecules. While soil organisms seek to use both sources of nutrients, they also need a source of energy for breathing, development, and reproduction. In mineral fertilizers, soil organisms that use the supplied nutrients will have to break down existing organic soil matter to reduce the organic soil levels associated with intensive agricultural systems. Boardman and Posen, 2006. Although all plants require nitrogen, organic or not, the potential impact of the organic approach, such as the method of collection and application of nitrogen, is significant on the environment, resource use, quality, and health. Reginald et al. 1987, Reginald et al. 1983, Mader et al. 2002. Production methods and food quality. Plant and animal breeding is well known to produce quality differences, such as between dairy breeds from Jersey and Holstein and between cultivars of frying and feeding wheat. Administrative methods can also influence the timing and amount of nitrogen fertilizer inputs, for example, which are vital for cereal protection and sugar beet sugar control levels. Management practices can be essential as well. We are also well aware of the influence of deficits in soil minerals on plant nutrition and animal-human health. Consequently, there is no doubt that how food is produced can often affect its quality. Therefore, a reasonable basis is provided to establish the scientific premise that food quality may differ from organic and non-organic systems. Whether for better or worse is another issue. The challenge of conducting an overall evaluation of the quality of organic foodstuffs is that organic systems are very varied globally, ranging from intensive horticulture to extensive mountain sheep and from tropical to Nordic climates and geography, with a wider variety of soil types and genetics. In addition to the rather broad conclusion that organic foods contain lower pesticide residues, which can be discussed, a favorable decision can hardly be reached that organic foods are always superior in quality to non-organics. Each of these reviews has individual shortcomings, but they all indicate differences, albeit the differences are unimportance-free, for example, by Danger et al. 2009. Thank you for your feedback. Please remember to subscribe to my next video.